I'm going to explain to you how, with this little blue sugar cube right here, 5 volts can turn on and off a 110 volt appliance. Yes, this is a relay, and I'll show you how it works. Alright, now we have our battery in the circuit here, and if you look at the illustration I've prepared, you'll see that 3 and 4 are the coils that power this device. The switch itself is, without any power applied, closed from pin 2 to 5. Now that's what we have here on the illustrative circuit. There's no power currently being applied to the relay at the moment. So that means the path from pin 2 to the common pin 5 is complete. The switch is closed, and it will remain that way permanently until 5 volts is applied to points 3 and 4. Those pins are the coil pins, and when power is applied to those points, the coil becomes an electromagnet. It has very much of electromagnetic properties, and that causes the switch to swing over to pin 1, thereby opening the switch, the path from pin 2 to 5. That is now open, so the green light will go out, and when the electromagnet activates by the electricity applied to the coil, the 5 volts, pin 1 and 5 will become the path, and that is where the blue LED is connected. So when I apply 5 volts to 3 and 4, like I said, that will cause the electromagnetic effect, and the switch will switch. So let's go ahead and give that a shot. Apply the 5 volts to that now, and hopefully the blue LED will light. And here we go. And that's the way it works. Now with the electricity there, as I said, the switch has switched over from pins 1 to 5, and as long as the 5 volts of electricity is applied to the 2 points on the coil, this will be the effect. Now that's how we can replace the LED in the 3.7 volt battery. That can be 110 volts, and that can be a lamp, and we still control it with the 5 volts because the power sources are isolated. There is no way they can come in contact with one another. The 5 volts through that coil in no way can contact the electricity that is flowing between currently pin 1 and 5. That's isolated power. So when we turn off the voltage to the coil, pin 2 to 5, the path from pin 2 to pin 5 is now the path conducting the electricity. And I could go ahead and remove the power connections, of course, and that path will remain closed. That is where the switch defaults to. That's the NC means normally closed. So even without the electricity applied to the coil, the NC path will continue to stay that way as the active path. But the moment we apply 5 volts to the coil, the switch changes. And the polarity to that coil is not important. We can have it from we can have positive at 3, negative at 4, or we can have positive at 4, negative at 3. Either way, that will work. And the power, like I said, between 3 and 4, the 3.7 volts is totally isolated from the 5 volts running between currently pin 1 and pin 5. And that's how, with 5 volts, you can control 110 volts. I hope that is easy to understand. If you have any questions, just ask me. Post them at the bottom. I'll have links to a tutorial as well on this with the descriptive images. So I hope it's understandable, and thank you for watching. Bye-bye.